Is it live now, boy? Right. Yes. Hello, everyone. I am Professor Pankaj Biswas. I am now in live session. If you have any queries, you can ask me questions. Yeah. First of all, I want to introduce about this course little bit. After that, whatever the queries you have provided to me, accordingly, I will respond to those queries. See, you all are very well familiar about this course name. This course name is Welding Application Technology. You know, as the name implies, in this course, generally I covered, or I can say I try to cover the fundamental overview of traditional and industrial welding technology, especially those welding processes which are widely used in the field of manufacturing industry. This course is, you can say, organized in such a way or arranged in such a way which will help the participant to understand and you can say apply this knowledge of welding in practice for various industrial applications. It will also encourage the participant to increase the research interest in the field of welding. That means in this course, I organize in such a way so that the student who are interested to do future research, he can also, he will be encouraged by this course content. Now, all of you are very well familiar about welding. Now, welding is a joining process where generally we join two metal or even non-metal part in such a way where generally its continuity is generally remains, that you can say. So welding is a process which is an unavoidable technology in most of the manufacturing sector, you can say. It is such a topic in which you will get the taste of most of the science and engineering subject. Like here, knowledge of almost all the science subject is required to understand welding, because that's why what happens in welding, you will find so many different subjects involved, like physics, chemistry, mathematics, and also in engineering subject, you will find the taste of what it's called solid mechanics course, thermal science course, fluid mechanics course. Generally, these are the courses which are highly essential to understand the fundamental knowledge of welding. So it is observed that in manufacturing industry, you know very well, around 35% expenditure is spent in what it's called welding or joining purpose. So welding has significant application in various manufacturing sector. That also you know very well. That's why this course is very much interesting to manufacturing types of industry, as well as what it's called in lot of academia who are particularly in the field of manufacturing as well as in design field. Now, this course generally will help the participant to understand and apply this knowledge of welding in practice for various industrial applications. It will also encourage and help the academic participants to increase the research interest in the field of welding. Now, first of all, I am briefly introducing about the course content. Though you are very well familiar because you have already completed few modules of this course. There you observe what is the course content. Then also I am briefing this again. So the brief overview of this course content generally contain you can say different types of very important welding process. Like in this course, I covered generally solid state welding process, especially friction stir welding process. You observe that this friction stir welding have a wide research work. You can say friction stir have a wide importance in the field of what is called manufacturing sector, as well as in research field. Because this is the latest technology, you can observe that. That's why in this course, I covered those topics. Apart from these things, some other important traditional welding process also I covered. Most importantly, I want to say in this course, I cover different types of very interesting topics which have a high importance, especially in the field of design. It's in the field of what is called life estimation of what is called a structure. So those related topics generally I covered in this course in details. Like in this course, you will find what is the test of what is called different types of welding defects and its inspection. What are the safety issues generally arise in different types of welding process? That related things I covered. And most importantly, I covered in this course the welding drawbacks, you can say. Because once we do the welding in a particular structure, there you observe that you can say there creates some different types of defects. So as well as those defects, as well as you can say some other what is called drawbacks, like once you do the welding in welding structure, that creates residual stress and deformation. These two are the most critical drawback, you can say, in the field of welding manufacturing part. So that's why what happens, what are those residual stress and distortion, that related details actually I discuss in this course, details in the field. This is the details in the in this field means here I covered what is residual stress, what is the cause, effect, why we can mitigate this residual stress, how we can measure those residual stress, and finally, based on considering those residual stress, how we can design a what is called a structure. That related things in details I have discussed in this course. Apart from these things, in this course also I discuss about what is called what is welding induced distortion. There are different types of distortion once you do the welding in a structure. Those distortion related fundamentals I covered in this course first. After that, I discuss how we can measure those distortion, how we can eliminate those distortion, how we can what it's called mitigate or reduce those distortion, and how we can predict those distortion or estimate those distortion. That related details I have discussed. So these are the different very important topics which have a wide importance in the field of what is called industrial manufacturing part, as well as these have a wide importance in the field of what is called research. So that's why once you go through this course regularly, you will find what is the importance of welding process and how we can utilize this, what is called different types of important aspects related to welding in actual field. That related things also you will get from this course. So that's why this course is designed in such a way where you can find that what is called where the manufacturing industry participant will get the interest, as well as the academia who are interested to do further research. He will also be benefited by this course. What I'm telling, understand? Now, apart from these things, in this course, I have also covered different types of very important, you can say, design aspects of welding, like what is called design aspect in the sense, because welding structural design generally considers some extra, you can say, aspects. So those different types of aspects which are considered generally welding analysis and design purpose, those related things in details I have covered in this course. Especially in this course, I have covered what is called design and analysis of butt and fillet welding joint, then strength calculation of different types of what is called weld joints, especially butt and fillet welded joint. Here I have covered the design of a welded joint or a structure which is subjected to eccentric type of loading. Then I also discuss here about the welded joint subjected to bending moment. That means if a welded joint subjected to bending moment, then how we can design that what is called a structure. That related things in details also I have discussed in this course. Now, so once you go through this course, really, what I want to say, you will get a huge interest in the field of welding, and you will get the idea where, how you can utilize this knowledge and how we can improve the weld quality or joint geometry with the help of this knowledge. That related thing also you will get from this course. So this course is really a very important course. Now, if you have any queries, you can ask me questions. Accordingly, I will discuss in this live session. Now, you also know these things. This course layout is arranged in 8 different, what is called, modules. So in week 1, or you can say different module, and 8 different week, you can say. This is a 8-week course. So this course is what it's called, categorizing 8 different modules. In first week, generally you already covered. Here I have covered the basics of welding, residual stress and distortion and its mitigation. In second week, I covered measurement and analysis of welding, residual stress and distortion. Third week, I covered measurement of welding, residual stress and distortion, because this is a huge topics. That's why it's contained 2 weeks. That means measurement and mitigation of welding, residual stress and distortion. That's why. Now, apart from these things, I covered in week 4 and 5 different types of important welding process, as well as different types of traditional welding process, which have a wide application in the field of manufacturing sector. Those related things in details I have discussed in this course. And finally, I discuss about the different types of design aspects. That means how to design a welding structure. That related to things I discussed in last 2 modules or last 2 weeks, you can say. So up to this, if you have any queries, whatever the portion you covered, if you have any queries, you can ask me the questions. Do you have any questions? If you have any questions, you can ask me the question. Actually, one of the participants who asked me a question, that question is based on what it's called residual stress. He asked me, sir, what is residual stress? Can you please brief these things a little bit? Yeah, definitely I can brief the concept of residual stress. So residual stress, what does it mean? Residual. That means you can say the stress which is residue or which is remain after removing of all external cause of that stress. That is generally called residual stress. This is actually locked in stress, you can say, inside a structure. Now we can say that how in a welding structure this residual stress is come into picture. So what happens in case of welding, once we do the welding, then you observe that in welding, they are generally little bit, I am just showing, then it will be very clear to you what happens in welding. So you observe that in case of welding process, let us consider this is your weld bit geometry, let us consider. So let us consider this is your weld bit geometry. Now, once we do the welding, so what we observe, this is your electrode and this is your arc. So once you do the welding, there occur generally, you can say, some non-uniform heating. Non-uniform heating in the sense which is not uniform throughout the thickness of the plate. So what you can observe, if you just calculate the temperature distribution throughout the thickness of the plate, you will observe the in top side, whatever the temperature will be, let's TP I am writing. And at bottom side, whatever the temperature you will get, let T bottom, you will observe that there is this temperature is not equal. What I am telling, understand? So it is non-uniformly distributed over the thickness of the plate. Okay. Now, due to this, what happens in this plate? You can observe that throughout the, you can say the temperature distribution. Let us consider top side is this mass Tp, and bottom side is, let us consider this is your Tb. So due to this temperature distribution, non-uniform temperature distribution, in the thickness direction itself, there occur a dT by, you can say, d thickness. That means temperature. Here I am just writing temperature, thickness is T. So this is called del T by del T, or you can say dT by d thickness. This is called temperature gradient. Temperature gradient. Due to this temperature gradient, you can say throughout the thickness, the expansion and contraction, because you know expansion and contraction will be different. In top side phase, as the temperature is more, that's why what happens here, the expansion will be more. At bottom side, as the temperature is less, that's why what happens, bottom side expansion or contraction will be less. That you can say. Due to this non-uniform expansion during heating time it is expand, and during cooling time it is actually, you can say, contract. Due to this during heating time, as it is expanded, how it is expanded, that is also very well known to you, because generally we know this. Let's thermal expansion coefficient is alpha. Thermal expansion coefficient I am writing. Now, what is thermal expansion coefficient? Thermal expansion coefficient means per unit degree centigrade temperature change, how much strain is coming. That is generally called thermal expansion coefficient. That you can see. Now, what is a strain? That's why what happens, this thermal expansion coefficient have a unit that is actually per degree centigrade, you can say. Degree centigrade or whatever, Kelvin, whatever it is, but degree centigrade. Okay, this you should keep it. That means per degree centigrade, how much strain is generating in a structure, that is generally called thermal expansion coefficient. So as at top side, so what is the thermal strain? Let us consider thermal strain. I am writing epsilon T. So thermal strain you can write as alpha into change of temperature, change of temperature, let delta T. So as this delta T is more at top side, so that's why this thermal strain at top side will be, so I am writing epsilon T at top side. Top side, this epsilon T at top side will be more than what is called epsilon T in bottom side. Let us call the bottom will be epsilon into delta T at this temperature change. This delta T is the, you can say delta T is the change of temperature. So you can say T minus initial temperature. That means Tf minus Ti, that you can write. So you see this alpha into delta T, as it is varying throughout the thickness. That's why what happens during heating side, one types of what is called expansion will be taken place at the top side. Another types of expansion will be taken place throughout the thickness, as well as bottom side. It will not be equal. That's why what happens, and during cooling time also same things happen, because during cooling times also this cooling rate at top side will be one type, bottom side will be another type, in between also another type. Due to these things, what happens, there occur a non-uniform heating and cooling. Due to this non-uniform heating and cooling, what happens, some layer of the plate, you can say, let us consider this plate I am representing into different layer. different layer. So this layer of the plate, if you represent the plate in layer throughout the thickness, so you will observe that heating during heating time as something is heating expanding more. So what happens? It try to cool down during cooling time, but what happens due to this non-uniform thermal expansion and contraction, all the layer is not possible to contract equally or expand equally. That's why what happens? Some layer is subjected to, you can say, some layer is subjected to expansion types of thing after cooling. Some layer is subjected to tensile types of nature after cooling. That you can say. Due to this reason, what happens? Here, what happens? Some stresses is developed inside the weld zone. So this inside the weld zone. Now, residual stress generally, always you should keep it. Residual stress is a the basic concept I am telling. In more details, I'll tell just in after this. So first of all, basic concept I am just telling. What is the cause of this residual stress? Main cause I am just telling, due to non-uniform expansion and contraction is the main reason of what is called residual stress develop in weld zone. Because if a plate, like what happens, if a plate, if you do heat it in a furnace and cool it in a furnace, which is a uniform heating and cooling, that means all the layer of the plate is subjected to uniform heating expansion and uniform contraction. So at that time, as the layer is not subjected to any types of what is called tension and compression effect after cooling, that's why what happens, there will not be any types of, you can say, residual stress. So residual stress will be there where there will be some, what is called, some layer, let us consider, remain after leaving of load, remain in expanding state. Some layer, let us consider, in contracting state. It's tried to return back to its original position, but due to this variation of thermal expansion and contraction, it is not possible to return back to its original position. So you can say the layer of the plate is subjected to some what is called straining after removing of or after cooling of the plate due to this non-uniform heating and cooling phenomenon. Due to these things, generally what it's called, the residual stress is developed, or you can say stress is developed inside the structure. Now, what is stress? You know very well. Stress means once let us consider this is a bar which is subjected to a load P. So if this load, if you apply load P, then you know this bar will be subjected to some elongation. Correct? Elongation. Let us consider initial length of this bar was L. Elongation is, let us consider delta L. So what do you mean by engineering stress? Engineering strain. So I am writing engineering strain equal to, you can write as change of length divided by original length, L0. This you know. Now, what is a stress? Well, generally, according to Hooke's law, you know this stress is equal to your epsilon E into Young modulus, E into epsilon. This is according to Hooke's law, you know. Hooke's law. This is very well known to you. So that's why once somebody is subjected to some strain. Yes, sir. Sir, I am in a live session. And I am live session. So you know this. So whenever it's subjected to some change of plane, then this change of plane by original length is called strain. So whenever there will be some strain condition inside the what is called structure, that means change of length, if it's remain, what I'm telling, understand? Then only this strain will come. And with this, if you multiply the Young modulus, then there will be some stress. But if a structure which is subjected to uniform heating and cooling, that means same expansion, same contraction, at that time, what happens? Furnace heating, like furnace heating case. in case of furnace heating, if you heat it, uniformly it will expand. Once it cool it, uniformly it is cool down. That you can say. So for those case, generally for thin section, you can say, for those case, the residual stress you can say will be 0 almost. Okay, but in case of welding, as one layer is subjected to more expansion, so once it try to cool, then subsequent which is less expanded, that will restrict that return back of this more expansion part to its original part. That's why there will be some strain part inside the structure. Due to this strain part, that means there will be some locked in stress inside the structure. This you should keep it in mind. This is the main fundamental cause of residual stress. This you should keep it in mind. Okay, now this is one reason. Apart from there is some other reason also. That's why what happens, like different categories of residual stress are there, like macro scale residual stress, micro scale residual stress, and you can observe that there is atomic scale residual stress. So macro scale residual stress, which is generally due to this, you can say macro level, means it's due to these types of phenomena, you can say, due to this what it's called change of thermal expansion coefficient, say thermal expansion and contraction. Due to these types of phenomena, generally this macro scale is. Micro scale means whatever the microstructural constituents are there, like ferrite, ferrite, different types of phase of steel are there. These phases also have some what is called different types of expansion and contraction during heating and cooling. So due to that, what happens, there is also occurs some non-uniform expansion and contraction in what is called microscopic level. Due to these things also what happens, you can say those types of phases generally subjected to some strain after cooling of the plate. There remains some strain of that phases after cooling also. Due to that things also, there can be some locked in stress in those types of phases also. What I'm telling, understand? This you should keep it in mind. Apart from these things, what happens in metallic structure, where can be some atomic level, what is called dislocation or some interference. Due to those things also, there can be occur some, what is called, due to this non-uniform expansion, there can be occur some non-uniformity. Due to this non-uniformity, there can be subjected to some what is called straining, and due to this some locked in stress also there can be developed. That's why what happened, due to these different reasons, different categories of residual stress generally can develop in a structure. So in welding generally, this macroscopic residual stress is as well as microscopic residual stress are more prominent, that you can observe, because here generally due to this non-uniform expansion and contraction phenomena is major issue, and as well as it is subjected to melting in fusion welding case. That's why what happens in this welding case, you can observe there the phase changes occur. Due to this phase changes, that phase changes also is not able to expand and contract uniformly. That's why I also said there can be some locked in stress there. So always you should keep it in mind, wherever there will be some uniform expansion and contraction types of phenomena, there will be generally generate locked in stress or residual stress, because one layer generally protect another layer to return back to its original position. So one layer will be subjected to tensile, another layer can be subjected to compressive. These types of phenomena generally it is subjected. This is one case. Just little bit general way I try to make you understand. Okay. Now let's see if you have any queries. More details I can discuss later on also. Yeah. Till now, students don't have any queries.
Good evening, sir.
Yes, very good evening. Do you have any queries? Why this, sir?
Yes, sir. Actually, I missed that assignment submission, sir. Due to the so first and second assignments I missed.
Yeah, you sent me that mail, correct? Yeah, you sent me that mail.
Yes,
na?
Sir.
So you want
yes,
that
sir,
you forget to submit this first one and second one, correct? So
Yes,
you
sir,
want
exactly.
actually for that, I don't have any objection, frankly speaking. But if the NPTEL team, what it's called, they permit you, then I don't have any problem, any issue. I can make separate question set for you. But first of all, whatever the remain sets are there, you complete those set, okay? And you try
Sure,
to
sir.
take the permission from NPTEL personnels, that you can say. After that, if they just permit immediately, we can make the question paper, because this is not in our hand, frankly speaking.
Yes, sir.
Because this,
Sir, actually,
this course,
how can I communicate to NPTEL team, sir? How can I approach, sir?
I think the way you registered, na, there I think there will be
Yes,
some
sir.
what is called contact number that generally, and that those are the things, are the mail address. So from there you can get the idea, right? Okay.
Okay, sir. Thank you, sir. Thank you.
Okay. I think you have not complete. You have messaged me. You have two I think assignment you did not submit.
Yes, sir. First and second, actually both are the same date deadline given. That too, there is no pop-up or any mail also not received. For the third assignment, I received mail, sir. For first and second, not received.
Definitely, I will help you.
Yes, sir.
What I am
Thank you.
telling, understand? Because you
Yes,
just
thank
talk
you.
with them. If they permit you, I will help. Okay. Thank you, right? Thank you.
Thank you, sir. Thank you, sir.
Any question, anybody? If any question you have, definitely we can discuss. Yeah, another question actually, someone of you actually called me and asked, sir, actually, what is the cause of residual stress? That things little bit I explained. But in welding induced residual stress related things, he has not asked. That things also I'll discuss if time permit. But another student who asked me said, which strain component is responsible for residual stress? Can you please elaborate the thing? Yeah, little bit that things I'm going to elaborate now. Okay. Yeah, you see, once we do the welding, then what happens? Like what happens? Let us consider this is the weld bit. Okay. Now in this weld bit, once we do the welding, what happens? It's subjected to, in case of fusion welding case, I am just telling. In case of fusion welding case, this weld bit is subjected to melting. So during heating time, so due to this, during welding times, you can say what are the strain component is there in weld joint. So total strain, that I'm writing total strain. So total strain you can represent as E epsilon total is equal to elastic strain plus plastic strain plus thermal strain. I am writing thermal strain is epsilon T. So during heating time, that you can say. Now you see, once it's cooled down, then this thermal strain part generally, what is called it, you can say convert to this elastic strain and plastic strain. So you can say it's convert to some elastic strain, that is I am writing this epsilon E dot plus epsilon P dot. That means this thermal strain is converted to elastic plus elastic. So this is generally after cooling, you can say. So you can say after cooling, then what happens? This total strain is combination of what is called elastic and plastic strain. This you should keep it in mind. Now this plastic strain, what you can write? Plastic strain you can write as epsilon total strain minus epsilon elastic strain. Okay, epsilon total strain minus epsilon elastic strain. So always you should keep it in mind. This plastic strain have a name, which is responsible for both, you can say, deformation as well as residual stress. Now I told you that residual stress is a locked-in stress. If you just remove that locking, it can return back to its original position. So which strain can return back to its original position? You know very well. Elastic strain can return back to its original position, correct? That things already you studied in what is called stress strain diagram. Little bit I am explaining, then it will be further more clear to you. Let us consider this is sigma and this is your epsilon. Engineering stress versus engineering strain. Sigma represent your stress, epsilon represent your strain, which both are engineering stress strain. For a duct yield point is called elastic point, or what is called yield point. This you should keep it. You know very well. So after that, if let us consider if your deformation come here. Let's initial yield point is A point and your deformation come here. But what happens once you release the load after point B, then it will not be possible to return back to its original position. Then what happens? There will be remain some. It will follow the path which is parallel to initial tangential line. But what happens? There will be some permanent deformation. There will be some permanent deformation which is called generally plastic strain. This you should keep it in mind. So I told you that this residual stress is locked in stress which is elastic in nature. That means if you remove that what is called locked or whatever the region of this strain part inside the structure, if you can remove that thing, then residual stress will be vanish. This you should keep it in mind. So that's why in case of residual stress, the residual stress is generally generated in a structure which is due to this elastic strain. So elastic strain generally is responsible for residual stress. This you should keep it in mind. Now, what is the epsilon total part? This epsilon total is responsible for distortion. This you should keep it in mind. So distortion means deformation, permanent deformation which is taken place in a structure. That is generally called distortion. Now you see, so what you can write? Plastic strain equal to, you can say total strain minus elastic strain. So this plastic strain, as it is responsible for distortion and what is called and residual stress, that's why this plastic strain also sometimes called as, because this is the inherent property of that. That means inherent property of that welded joint. That means distortion and residual stress is the inherent property of the what is called welded joint, welded structure. That's why what happens, this epsilon P also sometimes called as inherent strain. Inherent strain, or it is also called plastic. So always you should keep it in mind. Inherent strain is plastic strain, elastic strain is responsible for residual stress, and total strain is responsible for distortion. These are the points you should keep it in mind. Okay. It's a very simple concept. Now, that's why what happens? This residual stress also have a name that is also sometimes called initial strain, or it is also sometimes called internal stress. It is also sometimes called residual stress. Okay, because this is also sometimes called locked-in stress. Residual stress has different name. Now, this residual stress, how we can measure that, you know very well. Okay, this residual stress, what you have, I think you have not yet started those residual stress measurement related thing. This will come actually very soon. It will, I think it is module 4. It is in module 4. So there you will observe how to measure the residual stress distortion in details. So little bit I am briefing. Residual stress can be measured by different types of experimental way. So this experimental methodology you can group into 3 different categories. The first category is called destructive testing. Second one is called semi-destructive technique, and then third one is called what is called non-destructive technique. So you can write as DT, destructive residual stress testing, NDT, non-destructive residual stress testing, and semi-SDT. These are the different techniques generally we use. This one you should keep it in mind. We use to measure residual stress. Now, destructive technique means, you know this thing very well. Destructive technique means here you need to destroy your welded joint. That means you can reuse that welded joint further. That is to estimate the residual stress. There are different types of those destructive residual stress techniques are there. Like one of the example I am, you can say SAS boring technique, slicing technique. Okay, these are contour method. Some block removal method, different techniques actually, which will be discussed in subsequent modules in details. This one you should keep it. NDT techniques, where generally you need not to what it's called destroy the welded joint or welded structure by using some what is called you can say some very interesting what is called techniques. You can measure this thing like XRD. XRD techniques is a non-destructive techniques. Then you know this ultrasonic technique. Ultrasonic technique, which is also another non-destructive technique. XRD, it is also, there is some another technique, neutron diffraction also, X-ray diffraction technique, neutron diffraction technique also are there, diffraction. Then magnetic, some techniques is also there for NDT testing purpose. And semi-destructive techniques means here also you are destroying the workpiece, but what happens, that workpiece you can reuse in actual field. This you should keep it in mind. That is called semi-destructive technique. These semi-destructive techniques have different categories. That also you can observe in that course. These are all what is called experimental technique. So apart from these things, by some numerical method also, you can estimate the residual stress, or you can say you can predict that residual stress. What are those different types of what is called numerical method you can use to predict the residual stress? That related things also I have discussed in this course. So subsequently we'll learn in details about all these things. Okay. Now, if you have any queries, anything in your mind, you can ask me. I can clarify or I can answer your queries. In this live session, if you don't have any queries, no problem. Without live session also, you can mail me, you know, that your queries directly to me. So accordingly also, I can respond to your queries if you have. Now, someone of you actually asked me, sir, what should be the exam pattern of this course? So exam pattern, always you should keep it in mind. This is a one line, there will be online exam at the end of this course. That online exam will be considered generally MCQ types of question. Always you should, this is a MCQ type based question paper. So there can be around 70 to 80 numbers of questions. So that some question is 1 mark question, some question is generally 2 mark question. This you should keep it in mind. So accordingly, that exam, so exam weightage generally contains some weightage. Similarly, there are 8 different what is called assignments are there. So those assignment also contain some weightage. So finally, the cumulative, you can say, weightage will be considered for your final what is called grading purpose. These are the things you should keep it in mind. Okay. Now, if you have any queries, anything in your mind, I can discuss in live session itself. Otherwise, if you don't have any queries, you can directly mail me. In this mail also, I can discuss about this. Okay. Yes, we don't have any queries. So that's why I think we can quit actually. We can leave actually this live session. 1 minute. Hello? Do you have any queries? I think no queries. So, Betty, hello? Shall I leave? Hello? Yeah, but actually no queries are there. So it is already, whatever the queries they ask, I discussed. Okay. By phone itself. And now also there are no further queries are there. So I think we can quit. Correct? Okay, that because as there are no further queries, but no need to stay up to that full time, correct? That one, that's already we have completed 50. We can complete it 50 minutes. So thank you, right? So I am leaving this one actually. I am to say.